Hi, welcome back to the start of our next video for 4.1 special angles. We're now on page 223 in the textbook and we're going to do investigate B. So we're actually taking part of investigation A. We had drawn this 45-degree triangle on the unit circle. And now what we're going to do is we're going to use that to see if we can find trig ratios for angles greater than 90. So to do this, we actually take point A and we reflect it over the y-axis. When we do that, the x value changes sign, so it becomes negative, and this reflects directly across the point C. The y value of point C is exactly the same as A. So I'm actually going to write out the coordinates from point A. So we had 1 over root 2 and 1 over root 2. Remember, those were the lengths of the sides for the triangles. We had 1 root 2 over here and another 1 root 2 over here. And remember, the hypotenuse is just 1. This is a unit circle. The radius is always 1. Okay, so let's kind of follow through here. So it says line segment OA from investigate A forms an angle of 45 with the x-axis. Reflect point A and the y-axis to point C. We just did that. And join point C to the origin. Okay. What is the measure of the angle between OC and the negative x-axis? So what is this angle in here? Well, if it's a reflection, this also needs to be 45 as well. It says this angle is referred to as the reference angle. So the reference angle is always the acute angle between the terminal arm and the x-axis of the angle in standard position. So what this means is if I were to draw a terminal arm with an angle greater than 90, so like for example this one, this is my angle in standard position. It's probably like 135 degrees. I know you can't see that too well, but the angle that it makes with the other side on the x-axis, so the acute angle between the terminal arm and the x-axis, that's called the reference angle. So it says here the significance of knowing the reference angle is that the values of the 6 trig functions for any angle greater than 90 are the same as the corresponding values for its reference angle, with a possible change in sign. So it's basically what it's saying is all the trig ratios for this angle in here at 135 degrees, they're going to be the same as the trig ratios for the reference angle 45. So like sine of 45 will be the same as sine of 135. Or cos of 135 is the same as cos of 45. It says the only difference is there might be a possible change in sign. So when I go to draw this triangle, okay, down here, notice this side, it's now negative because it's in the negative x quadrant when I measure this length. So that's how we're able to develop negative values for the trig ratios. Okay, let's go ahead and see what part 2 is looking for. It says, what are the coordinates of point C? So we can write that up here. Point C, that's going to have the ordered pair. So remember, it's the reflection of this point along the y-axis. So that means x changes sign. So negative 1 over root 2, comma, positive 1 over root 2, because the y value doesn't change. Okay, what's question 3? Look back at the relationship found in step 7D of investigate A. Use the coordinates of point C to determine cos of 135 and sine of 135. So if you remember from the other investigation, the value of point A, remember the x value had to do with cos of 45 and the y value had to do with sine of 45? Well, for point C, this now has to do with the angle 135. So it would be, the x value is actually going to be cos of 135, and the y value is sine of 135. So let's also write that in here. So this represents cos of 135, and this represents sine of 135. So we can use that to figure out the ratios. We could say cos 135 is equal to negative 1 over root 2, and sine of 135 equal to positive 1 over root 2. All right, step 4. It says reflect. How can you use the coordinates of point C to represent tan of 135? So how can I use this point to get tan of 135? Well, that's kind of easy. Like, remember, tan of this triangle right here, it's going to be opposite over adjacent. Well, doesn't this side represent the y value? And doesn't this side represent the x value? So if tan is opposite over adjacent, it's actually just going to be the y value over the x value. So tan of 135 is going to be the y value over the x value, which would be, remember the y is, well, I can write it this way, 1 over root 2 divided by negative 1 over root 2, which is going to work out to negative 1. Okay, and remember, since this is cos and that's sine, it's actually sine 135 over cos 135. So I'm going to write that beside here, just so you can see. It's the same as sine 135 over cos of 135. So this is actually one of the properties about tan. Tan of an angle, it's always equal to sine of that angle divided by cos of the angle. All right, so question 5, it says find tan of 135. Well, we actually did that. So question 4 wanted to know how to use the coordinates, and I kind of showed you how to use them here, and then we found the value. It worked out to negative 1. So this is actually 5A. 5B, it says find the slope of the terminal arm OC. How does this relate to the tan of 135? So it says find the slope of OC. So the slope of this line. So if you look at it, you can see that we're cutting through the grid diagonally. So nice and even on a 45, which we know it's 45. I can tell it as I go down 1, I go over 1 each time. So the slope should just be negative 1. So we can say that right here. Say n is equal to rise over run, and it works out to negative 1 because we go down 1 over 1. So notice that's actually the value of tan 135. So the slope of the terminal arm is equivalent to tan of 135. So it actually works out for any angle, whatever you draw the terminal arm, the slope will be the value of the tangent ratio. All right, last question 6. Use a calculator to compare the trig ratios that you found in steps 3 and 5 with the calculator value. So here we have found cos, sine, and tan. Okay, there's tan's actually right over here. I'll include that in. So let's go ahead and check. So cos of 135, we should see a negative 0.707. Make sure we're in degrees. There we go. Sine of 135, this one will be positive because the y value is positive. Yeah. And tan, we should see negative 1. And we do. So we can see they're the same. The calculator values match our answers from the unit circle / triangle. Okay, so that's it for Investigate B. I'll see you guys in the next video where we start our final investigation, Investigate C.